What's the best way to call a new SwiftUI API when you also need to still support older iOS versions? With WWDC and the new iOS version being just around the corner, it seems like a great time to go over this topic. I found an article that basically said all I wanted to say, so let's go over it. As always, the link to the article is in the description. Let's start with the basic building block of using an API that is not supported on all of the versions of iOS that your app supports. What you'll be using is this thing here. So if pound available and then the version of iOS, or on the other hand, if pound unavailable for the rarer cases where you need to do something specific only on older versions. But of course, most SwiftUI APIs are view modifiers, and you can't directly use an if statement when you're in a chain of modifiers being called. So you also need to have a way to wrap this if statement into something that can sit inside a chain of modifiers being called. So how do you do that? The easiest way is to declare an extension on view and implement a modify method that will take a closure inside of which you'll be able to use the if statement and then call the closure inside the modifier. So how does it look like to use it? Here we are inside the body of a view and we're calling this modify function on this section view. The section is being passed here as a parameter, and inside the closure, we can use the if available statement to do a differentiated code path depending on whether we are running on a device that supports iOS 26 or higher, so inside the if statement, or if we're on a device which is running an older version, we'll go into the else statement, in which case we just return the view and don't do anything to it. Now you can see that there are two warnings just below, and these warnings are important to understand. The first one is that you always want to return something in the else statement. Because the closure has been marked as add view builder, I'm pretty sure that if you don't return something, you might not get a compiler error and it might actually be automatically translated to an empty view, which in most cases will not be what you want. And the second warning, a much more important one, is that you might have read in the past that this approach of applying a modifier that does an if statement inside a closure is a bad practice because it breaks the way that SwiftUI reasons about the identity of a view, and so it could break things such as animations or transitions. But while it's totally correct that in general it would be a bad practice, in this case, it's totally correct because the condition that we're evaluating, so whether or not we're running on iOS 26, is never going to change while your app is running. So you run no chance of the view identity being broken. It's one of these cases where it's okay to use such a pattern. However, I think we'll all agree that having this kind of if-else statement popping up everywhere inside the bodies of your views is not the best practice in terms of organizing code. So now we'll see how we can get the same functionality than what this approach gives us, but in a way that gives us cleaner code and something that is more manageable and that will also make it easier once you stop supporting the older version of iOS to find the code that needs to be deleted. The first approach is for the specific case where you only need to return a different value depending on the version of iOS. You're still using the same modifiers, it's only the value of the arguments of these modifiers that needs to change depending on the OS that the device is running. In that case, you can simply define a top-level generic function like this one. So this function is called value, takes a generic type t, and then two parameters, both of type t, but one for when you're running on iOS 26 and one when you're running on iOS 18. You could add, of course, more versions of iOS or do something iOS 26 and iOS 18 and lower, if that makes sense for you. And then inside the function is where you will encapsulate the if available test, where you'll return the right value depending on the OS that the device is running. In practice, a call site will look like this. So where you would have had a value, you will get the value function being called with first the value to use on the most recent OS and then the value to use on older OSs for compatibility reasons. Personally, I really like this approach because it happens quite often that you just need to provide a slightly different value depending on which version of iOS your app is running on. It could be because maybe some SwiftUI views behave slightly differently, and so you need slightly different values in padding, like here. Or it could be because in a more recent version of iOS, you've added a new UI element, and so you need to tweak the layout to accommodate for this new element. And there's even one more thing that you could do, which is not shown in this article, but it would be to also annotate the value function so that it's marked as deprecated once you're no longer supporting iOS 18. This way, the day that you stop supporting iOS 18 inside the configuration of your app, then you will automatically be getting compiler warnings and errors that will point you to all of the call sites where this function is used so that you can remove the compatibility values that will no longer make sense. Now let's move on to how we can improve the code when we are in the general case, so when we need to call a different set of modifiers depending on the version of iOS that the device is running. The basic approach is fairly straightforward. Instead of using the modify function everywhere in which we put the if statement directly inside the SwiftUI code, what we do is that we create specific functions for each of the modifiers that we want to call with this compatibility layer. We give them an appropriate name, and inside the function, we do the if else with the differentiated treatment. Now, while this is already much better than having if-else statements starting to pop up in the bodies of your SwiftUI views, this approach can be improved even more. What you can do is rework the code so that you first start by declaring a struct called backport. This struct is generic, so we can see a similarity with the modify function that we had at the beginning. Then you declare an extension on view. In this extension, you add a property of type backport, and you implement it by returning a backport that takes self, so the view, as a parameter. Once again, looks very similar to the closure that would take the content as a parameter. And finally, inside an extension of backport, you implement the compatibility modifier where you give it the same name than what the modifier has on the newer version of iOS. And inside the body of the function, you implement the if statement with the differentiated treatment. What's really great with this approach is that first, the call sites look really neat. You have an explicit .backport, which lets the reader know that this is not only the native implementation, but there is also a compatibility layer, which could be doing nothing, which could be doing something that emulates or approximates the new behavior. At least the reader is aware that it's not just the plain SwiftUI API, there is something more here. It also makes it much easier if you need to search and replace to find out where in your code are you using this kind of compatibility layer. And finally, you can see right here that we're doing a conditional conformance, which means that here, this method will only be able to be called when content, the generic argument here, is of type view. So this is the most common type in SwiftUI, but this is super useful because it means that if, for example, you want to use a new modifier that is only available on text, you'll be able to use text here instead of view. And this way, your code will be much safer because Swift will only allow you to use the compatibility modifier when you're calling it on an actual text and not on any kind of SwiftUI view. So you're getting extra safety when you're using this approach. And that's it. This is everything I wanted to show you on the topic of how to call newer SwiftUI APIs when you're still supporting older versions of iOS. I have a big thank you for the author of this article, and fingers crossed, we'll very soon get some new exciting SwiftUI APIs announced at WWDC, and it will be the perfect opportunity to put all of this into practice. Thank you for watching and see you next time.